So this video is on the derivative rules with trigonometric functions. Let's first answer this question. What are the trigonometric functions? So basically, we really just have two trigonometric functions. So let me just write these down. F of x is equal to, let's do sine x, versus another function, trigonometric function, g of x equal to cosine of x. The remaining trigonometric functions can be written in terms of sines and cosines. For example, h of x equal to tan x. It's equal to sine of x over cosine of x. Or if we have the cosecant function, so cosecant of x, this is really just 1 over sine of x. Whereas the secant function, so secant of x, is equal to 1 over cosine of x. And to remember these two, I just remember it's always opposite the first letter. So this first letter is C. Let's highlight this. So the first letter here is C, then it's 1 over sine. For secant, since the first letter is s, it's 1 over cosine. And then the last trigonometric function we're going to work with today is the cotan function, so cotan of x, which is equal to, well, we could just say 1 over tan x to follow the pattern of the others, or it's the same as the flip of the tan function, so cosine of x divided by sine of x. And so the moral of the story is all you really need to know are sines and cosines, and if you can understand those, you can understand the rest of the trigonometric functions. Now, where do these functions come from? This is a pretty important question that hopefully a lot of you either know the answer, or when I give it to you, you'll be able to follow it. The idea is you can come from this right triangle. And so for this right triangle, let's draw it. Here's my right triangle. And what you have is an angle, and we can call it theta, but since we're using the letter x, I'm going to just call it x. And so that's x. Actually, I'm going to call it theta. We will use this later, and I don't want you to always think of this as x. So let's call this angle theta. And what we have here is an opposite side, so let's just call this OPP for the opposite side. We have the adjacent angle, the adjacent side to theta, and then we have the hypotenuse of the triangle. And this is a right triangle. And the way that cosine functions and sine functions are defined in the beginning, to understand what they really are, we can say this little so, ka, toa. What did the Indians say? Right, SOHCAHTOA. And so means the sine function, the sine of theta, is really the opposite side over the hypotenuse. And the lengths of these two sides divided. And the cosine of theta is just equal to the adjacent side over the hypotenuse. Right, so ka, adjacent over hypotenuse, so opposite over hypotenuse. And of course, tan of theta is toa, so oa, opposite over the adjacent. So that's how these trigonometric functions were originally defined. You took measurements of these sides, and you'd measure the opposite side, and then measure the hypotenuse, and then the sine of theta would be that ratio. I mean, you could literally take out a ruler, and let's say you had an angle here. Let's say this angle was, let's say this was equal to 45 degrees. And what you could do is you could take out a ruler, and you can measure the side right here. And let's suppose you found that was actually 1 foot. Well, let's say you measured the side, and you found this to be 1 foot long. When you measured the other side over here, when you measured the hypotenuse, what you would find is that this side was actually about square root of 2 feet long. That's what you would find if that was a 45-degree angle. And so then we'd conclude that the sine of 45 degrees is equal to 1 over root 2. And of course, when we rationalize the denominator, which means we turn that root 2 into a nice rational number, so 2, we multiply top and bottom by root 2, we get root 2 over 2, which is what you're familiar with as the sine of 45, or we could say the sine, if we write this in radians, pi over 4 is equal to root 2 over 2. So hopefully you understand a little bit where the sine and cosine functions come from and how the rest of the trigonometric functions can be written in terms of these things. The history of these are pretty fascinating. You know, the idea really is if you want to figure out the height of an object, like suppose you have a pyramid here. This is my badly or poorly drawn pyramid. Suppose you have a pyramid and you're standing, let's say, right here, and you know this distance is, let's say this is 100 feet. And what you can do then is you can take a sighting device and look at the peak up here. So let's do this in red. You take a little sighting device and you look at this peak up here through that sighting device, and what that gives you, this is supposed to be a straight line, this gives you a little angle here. So suppose your angle was, let's say, 20 degrees. All right? And let's make it even better. Let's make it 30 degrees because I can tend to this number. And what I really care about is, you know, what this height is. I'm looking to try to figure out, in general, you know, what is this height of the pyramid? Right? What is this h? And I guess we'll call it capital H. And so I can figure this out because I can use some trigonometry. I know that the sine, and let's not do sine, let's do tan. That'll make it a little bit easier on us. I know that the tan of 30 degrees, so the tan of the angle, so the tan of theta, is equal to, and let's write 30 degrees for that. The tan of 30 degrees is equal to the opposite, which is h. So it's equal to h divided by the adjacent, which is 100 feet. And so then I can solve for h, and I get h equal to 100 times tan of 30. And if you think about what tan of 30 is, you'll see that this is 100, the sine of 30, divided by the cosine of 30, which we can figure out then, you know, from our table, which we did before. So we have 100 times, and let me just remind you about our table over here. So we have 0, pi over 6, pi over 4, pi over 3, pi over 2. Oops, that's 2 there. And then we have cosine of theta. Our theta is right up here. And then we have sine of theta below it. And the idea is you just have to remember that the cosine of 0 is 1. So it starts with root 4, root 3, root 2, root 1, root 0. And these are all divided by 2's. So every single one divided by 2. And then, of course, the sine is exactly the same, but the opposite way. So square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. So this is just a simple way, divided by 2, 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 to sort of remember the sine and cosine of these these little reference angles. And so this is equal to the sine of 30, which is really pi over 6. So let's do this in red. So we look for the sine of pi over 6, which is just this number right here, 1/2. So I have 1/2 on top, divided by the cosine of root 3 of 30, which is root 3 over 2. So I have root 3 over 2. And so this is equal to 100 times, And what do we get? 1 over root 3? 1 over root 3. And so I can pull out my calculator here, and I can do 100 times 1 divided by the square root of 3. And I can approximate the height of this pyramid. So it must have been a very small pyramid. So approximately 57, or let's just round the nearest foot, so approximately 58 feet tall. All right, so moving on, what we want to do next is we want to talk about the various rules on how to differentiate trigonometric functions. So let's write down the rules here. So right above here, I'll write down the trigonometric rules. And so there's really 6 of them. And let me just copy them down first, and I'll talk a little bit about how I remember them as I copy them down. So let's start with the first rule we have listed, which is Ddx of Sine X. So Ddx of Sine X is equal to, and it's exactly what I would like it to be. I mean, I would like it to be Sine X. I mean, that's the easiest one. But the only derivative that it's itself is e to the x. So this one actually turns out to be almost as simple. It's just its partner, cosine of x. And then ddx of cosine of x, it's almost sine of x. You just have to remember there's a negative sign. So negative sine x. And then finally, ddx of tan x. This turns out to equal secant squared x. So remember, if I write this 2 above here, right, this means secant of x squared. So secant of x all squared. It's just shorthand notation when we put it in the middle there. Now the remaining rules kind of just follow from these 2 rules, really, the derivative of sine and the derivative of cosine. And I'm going to show you how this works a little bit later. But in the end, you'll probably just memorize them. So ddx of cosecant of x will equal something. And then ddx of secant of x will equal something else. And then ddx of cotan of x, again, will equal something else. So something else is, so to remember these, I usually know the derivative of secant x. So the derivative of secant x is secant x tan x, and then this one follows the same sort of form, except instead of positive, it's going to be negative cosecant x. Instead of tan x, it's going to be the partner there, cotan of x. And then for cotan of x, well, the derivative of tan x was secant squared, so this is going to be minus cosecant squared x. One thing you might want to notice that helps maybe to remember which one's negative. If it's a like cosine, it's negative. If it's a cosecant, it's negative. And if it's a cotan, it's also negative. So the derivative of when you take the derivative, is always negative. So that helps me remember when to put the negative sign on there and when not to. Now all of these rules, the derivative of tan, the derivative of cosecant, the derivative of secant, and the derivative of cotan, can be derived or can be found by knowing these 2 rules here. And I'll talk a little bit later how we can do this. But first, let's just practice a little bit using these 4 rules, or using the first 4 rules on your sheet along with the trigonometric rules. And so on here, let me copy this problem down now. All right, so over here I have f of x equal to what? So this is equal to 3x to the fifth plus 4 cosine x plus a tan x. And this is example 1. And I want to take its derivative, so I'm going to start off always writing f prime of x, so I get my brain into gear. And this is going to be equal to, well, the first one's just a power rule, so the 5 comes down. I get 5 times 3, which is 15, x to the 4th, so nothing new there. Plus, now I need to take the derivative of 4 cosine x. Well, this is just a constant times a function, so it's just the constant, times the derivative of cosine x, which is a minus sine x. So minus sine x plus the derivative of tan x, well, that's just secant squared x. And so I'm just using these rules over here. So the derivative of tan x right here is just a secant squared x. And I'll clean this up a little bit. So if I come down here, this is going to be equal to, and I just copy down the 15x to the 4th. Then I have minus 4 sine x. And then finally plus secant squared x. And so that's how I take the derivative of a function involving cosine, the cosine function or the tan function. All right, let's step things up a little bit. So let's take a look at when we use the product and quotient rules with these trigonometric functions. So example 2, part A, I have this g of x equal to 2 times e to the x sine x. And so hopefully you notice here, which rule am I going to use first? And you say, well, I have the first function, which is e to the 2x, times the second function, which is a sine x. And so since I'm multiplying, I'm going to use the product rule. So I have g prime of x equal to the derivative of the first, which is just 2 e to the x, times the second, plus the first, so plus 2 e to the x, times the derivative of the second. So remember the derivative of sine x was just cosine of x. And so then this is equal to, factor out what they have in common, so they have a 2 e to the x in common, so it's 2 e to the x. And we play this little game, something goes there plus something goes there. When you multiply by this, I get that. So what is that? It's just a sine of x. And then over here, what times this gives me this. And of course, that's just cosine of x. And I'm all done. So I can leave it just like that. The next one, let's do this one down here. I have part B, h of x equal to cosine of x divided by x plus tan x. And so when I see this type of function, I realize, okay, well, the last one was a product rule, so logic would tell me that this is a quotient rule, and indeed it is, because I have a high function and a low function. And I know the rule is low d high minus high d low all over low squared, and away we go. So down here I can write h prime of x is equal to, and I have the low function, so just copy it down, x plus tan of x, all times the derivative of the high function. Now the derivative of my high function, right here, derivative of cosine, since it's it's minus, and this is in sine of x, and then minus the high function, which is cosine of x, times the derivative of my low function, which is 1 plus, and this is secant squared x, all over what? All over my low squared. So x plus tan of x quantity squared. And now the rest is just some algebra, so let's just clean it up a bit. So to clean this up, I'm going to multiply through by this negative sine x. So I'm going to take this negative sine x right here, and I'm going to multiply it to the tan x and to the x. So I'm going to get minus x sine x minus, then I have what? Sine of x tan x. And then I'm going to multiply this cosine of x to the 1 and then to the secant squared. So I'm going to get minus cosine of x times 1 is minus cosine of x. And then minus cosine of x times a secant squared x. I'm going to get one of the cosecants canceling here, so I'm just going to get a minus secant x. All right, remember, if you take a cosine of x times secant squared of x, it's really equal to a cosine of x times 1 over cosine squared x, because that's what secant squared of x is equal to. And of course, one of these cosines on top will cancel with 1 on the bottom, so this will be left with just a secant x, because 1 over cosine of x is just a secant x. And then this, of course, is divided all by what? All by the low squared, so by x plus tan of x quantity squared. All right, and this is my answer. If you want to, you could factor out a negative sign on the top since everything's minus, but it really doesn't matter. All right, the next question, the next example we want to look at are these trigonometric rules and then involving the chain rule. And so example 3, what I have here, part A, is f of x equal to sine squared x. Now remember, sine squared x is really, and I normally don't write this, but just so you can see what I'm thinking, is really sine of x all squared. So you actually have an inside, which is right here, and then you have, which is a sine of x, and you have the outside, which is the square part. And so it's a chain rule, and the chain rule says the derivative, f prime of x, is equal to the derivative of the outside, so that 2 comes down, so I have 2 sine of x to the first power, times the derivative of the inside, so the derivative of sine of x is cosine of x. And so this is just equal to 2 sine x cosine of x. And this is a fine answer. You can leave it like this. Or you could actually write this, if you remember our identities, this is the same thing as sine of just 2x. But this answer above it, right here, is fine. I would probably just leave it like that. But know that it could also be written like that. The next one's a little bit more involved. So if we look at this next problem, right here, part B, let's copy it down. So on part B, what do we have? We have g of x equal to e to the negative 2x times cosine of squared x. And hopefully, as I wrote this down, you realize that I'm multiplying these two functions right here. So there's a multiplication sign right here. And so we're going to use the product rule. So I have my first function, and I have my second function. And I simply use the product rule, which says the derivative of g of x, so g prime of x, is equal to the derivative of the first, which is e to the negative 2x, derivative of the outside, times the derivative of the inside, which is a negative 2. Right, so remember, this inside here, the derivative of negative 2x is a negative 2, times the second, so this is part of the product rule, cosine squared of x, plus the first, which is just e to the negative 2x, times, now here's where we have to take the derivative of the second. It's not derivative of the second. Remember, this is actually another chain rule because it's all raised to the 2 power, so the 2 comes down, times cosine of x to the first power, now times the derivative of the inside, now the derivative of co is minus, so it's minus sine x, or times the derivative of, times negative sine x. Let's clean it up. So let's just write the number first here, so minus 2 e to the minus 2x, cosine squared x, plus, and that's not plus, that's going to be minus now, so let's delete that. So I look over here, and I see I have a minus sign right there, and so this is going to equal minus, and then I have 2 e to the minus 2x, cosine x, and sine x. And so I just rewrite it so the numbers are out in front, and then it's real easy to figure out what you pull out. It's what they have in common. So if you look at this thing, they certainly have a negative 2 in common, so I'm going to first factor out the negative 2. And so I have negative 2. And then they also have an e to the minus 2x in common. So I'm going to pull out an e to the minus 2x. And then if you look at it, is there anything else they have in common? And hopefully you say, yeah, they have a cosine of x in common. One's squared and one's just raised to the first power. So I'll factor out the lowest power, cosine of x. And then I'm going to play this game. Something goes here, and this is going to be a plus because I took out a negative 2. And then something goes there. When I multiply it by this, I get the above back. And so if you think right here, you're going to put a cosine of x, because then this times this will be what's above. And over here, I'm just going to put a sine x. And you can leave it like this. It's all done. So here's my answer. And then finally, on part C, it's probably going to be the most complicated, so you might want to take a break for a minute and come back. But here we go. So h of x is equal to the square root of 1 minus sine x divided by 1 plus cosine of x. And now before I can take the derivative of this, I need to get rid of the radical. I need to rewrite it in power form. So this is going to be 1 minus sine of x divided by 1 plus cosine of x, all raised to the 1/2. And now when I do this, I see immediately that there is an inside, and then there is also an outside. So if you look here, you'll see here's my inside, and then the 1/2 right over here is my outside. And so now I'm going to take the derivative of this thing. And so to take the derivative, I'm going to use a chain rule. So the chain rule says the derivative of h prime of x, is equal to, and it's a derivative of the outside, so the 1/2 comes down, all times 1 minus sine x divided by 1 plus cosine of x. And then the positive 1/2, you take away 1 and you get negative 1/2, so it's just a power rule, so derivative of the outside. And then times, now here's where it becomes tricky, the derivative of the inside. Now the derivative of the inside, here's the inside here, I circled in green, I'll circle it again. And there's a high function, and there's a low function. So remember, it's low d high, so what I have here is the low function, which is 1 plus cosine of x, times the derivative of the high, which is just a minus cosine of x. So notice this. Let's highlight this. The derivative of the high function. So take a look at the high function, which is 1 minus sine x. The derivative of 1 is 0, and the derivative of negative sine x is just the negative stays, and you get cosine of x. And then minus the low function, which is the high function, sorry, 1 minus sine of x, then times the derivative of the low function. Now, the derivative of the low function, take a look at it. Here's the low function. Its derivative, well, derivative of 1 is 0, whereas the derivative of cosine of x is minus sine x. And then this is all divided by low squared. So all divided by 1 plus cosine of x, quantity squared. Whew. So there's the derivative, and the rest is just going to be some algebra. So on top here, let's just work this out. So I'm going to multiply through by a negative cosine of x. So I'm going to get minus cosine of x minus cosine squared x. So I just multiply this by 1 and this by cosine of x. Then over here, this is going to become a plus. The minus is going to become a plus because that's a minus sign. And then I'm going to multiply my sine of x here by 1. So I'm going to get plus sine of x. And then I'll multiply my sine of x by minus sine of x. And so I'm going to get minus sine squared of x. And so let's rewrite this down here. So this is going to be equal to, let's go back to black. So this is going to be equal to, I have 1/2. And then if you let me, this minus sign means I can just flip these two terms here. So I'll put the cosine of x on top, 1 plus cosine of x on top, and 1 minus sine x on the bottom. So I get 1 plus cosine of x divided by 1 minus sine of x, all raised to the positive 1/2 now. And then on top, I'm going to rearrange these terms a little bit. I'm going to have positive sine x minus a cosine of x, and then minus cosine of squared x minus sine squared x, and then all divided by the bottom, that low squared. So 1 plus cosine of x, quantity squared. And now when I look at this, something jumps out at me. And it might not to you, but hopefully eventually it does. Now what jumps out at me is this minus cosine squared minus sine squared. Because I know, what do I know? Well, up here, I can tell you that from an identity, I know cosine squared of x plus sine squared of x is actually equal to 1. Right? This is a trigonometric identity. It's the most basic identity, which everybody should know in this class. And so if cosine squared plus sine squared is equal to 1, then if you take the negative of it, you just get negative 1. So this should be equal to then 1/2, and on top here I'm going to write 1 plus cosine of x to the positive 1/2 divided by 1 plus sine of x, and this is also to the positive 1/2. Right. And then here I'm going to write, instead of minus cosine squared minus sine squared, I'll realize that's just a negative 1. I'll write this as sine of x minus cosine of x minus 1, all divided by this low squared. So 1 plus cosine of x, quantity squared. Now I'm not quite done. Yes, I can go even further because they do have, if you notice on top, there is a 1 plus cosine of x, and on bottom there's a 1 plus cosine of x. So what I could do, and I actually made a little mistake here. Let me fix that. So this is not plus here. That's actually minus. So what I can do here is I can write this as equals, and let's just draw one big line, one big vinculum. And so here I have sine of x, and then minus cosine of x, minus 1. And then I have a 2 on the bottom, and then I have a square root, 1 minus sine of x. And then here, this green, the 1/2 will cancel with the 2 a little bit, and this will be 3/2. Remember, exponents here basically subtract. So if you have a 1/2 on top and a 2 on the bottom, it's the same as having a 3/2 on the bottom. And so I could then rewrite this as what? I could write this as, let's see, 1 plus cosine of x all times the square root of 1 plus cosine of x. And I think I'll just leave it like that. So this is my final answer. I wrote it, back in radical form because, again, they gave it to me in radical form, so I was just trying to follow all the rules that were set up in the beginning by the person who made the problem. All right, one last problem to talk about. Example 4. What happens if you forget some of the rules? So let's do a hypothetical here. So suppose I know, the derivative of sine of x. That one's usually pretty easy. That's the cosine of x. And we typically remember the cosine of x, the derivative of it is minus sine of x. But suppose I forgot, let's say, the derivative of tan x. I don't know what this is. What can I do? Well, one thing I could do is I could write tan of x in terms of sines and cosines, so it turns out to be sine of x over cosine of x. And then I could use the quotient rule on this to find the derivative. And so that's one approach to solving that problem. So we're going to do that, but we're going to do it with this secant function here. So let's go down below, and let's copy down the problem. So this is example 4. And I have my f of x equal to secant x, which is, this is a rule that I might forget if I don't use it a lot, but I know that secant x is 1 over cosine of x. And I know how to take the derivative when I divide. I use a quotient rule. So I know that this is my high function is 1, my low function is cosine of x, and I can copy down the quotient rule, low d high, minus high d low, all over low squared, and away we go. So down here, I'll write f prime of x is equal to, and I just copy it down. So my low function is cosine of x, times the derivative of my high function is 0, minus my high function, which is 1, times the derivative of my low function. So what's the derivative of cosine of x? Well, that one I know. That's minus sine of x, or negative sine x. And then all divided by my low squared. So cosine squared x. And so this is equal to, now think about this, if you take anything times a 0, this first term is just 0, and then a minus times a minus is a plus, so on top I have sine of x, and then on bottom I have cosine squared x. And now that doesn't look like one of my rules that I had to memorize but forgot, but if you rewrite this as 1 over cosine x times sine of x over cosine of x, which is the same thing, you suddenly realize that this is, yes, the secant of x times the tan of x. And so now I found the rule for secant x when I take its derivative by simply converting to sines and cosines. And in this one, I just had to convert it into cosines because the secant of x is 1 over cosine of x. And you can do this for any of the other rules that we typically do forget because we don't use them as often. So at times I'll have to take out these trig identities, secant x equals 1 over cosine x, and then use the quotient rule on it to remember that, oh yeah, the derivative of secant x is secant x tan of x.